Good morning, dear students. So here we will discuss once again PDA constructions A power n, B power n. Okay, so this is the language they have given. Okay, so now what we will consider the strings in this. If you take n is equals to 1 means AB, n is equals to 2 means AABB, 3 A's, 3 B's. So like that it's a infinite language. So we will consider any one of the string. For example, if you have taken 3 B's, 3 A's, then what we will do? Whenever we are reading a here PDA, right? So that's why we will have one stack. So Z0 is the top of the element. While we are reading A, then we will push it onto the stack. While we are reading the second A also, it will be pushed onto the stack. While we are reading the third A, then each and every A will be pushed onto the stack. And while we are reading the each and every B, then we will pop one A. Okay, so A means push operation, B means pop operation. While we are reading the first B, we will pop top A. While we are reading the second B, we will pop second A. While we are reading the third B, we will pop the last A. Then like that we just left with the empty stack. That is nothing but this string is accepted. Okay, so this is the concept we have explained in the previous classes. Okay, so now we will see if we got three symbols, how we have to do this problem. Okay, so I will explain the overall concept of this problem. Then how to write the IDs, transition functions, you already know that. So when we are pushing, how you need to write the transition function when we are having no change condition and pop operation, then you know that how we need to write the transition functions. Okay, see none. So first of all, if you consider this language, here A, B, C, three symbols are there. Here A power n, C power n means A and C both are equivalent here. If A is 1, if we take 1A, 1C. If you are taking 2 A's, then 2 C's. But B here we can take starting from 1 onwards, but it can be varied. So we will consider it as the constant value. See, we can take like this. For example, if we take n is equals to 1, m is also 1, then what will be the string here? A, B power 1, B, C power 1, C like that. For example, if you are taking n value 2 but m value only 1, then what will be the string here? N value 2 means 2 A's, B power is 1, so that's why only 1 B, then 2 C's. We can take in any combinations. Okay, for example, if you want to take, you can take n is equals to 2 and m is equals to 2. Then what will happen? A and C powers are 2. So that's why 2 A's and B power also 2. 2 B's, 2 C's. So like that we can consider. You can consider any of the combinations. But while we are doing this problem, you just consider one stack and here Z0 is the top of the stack here. Okay. So now for example, if you have considered 2 A's, B and 2 C's. This is the string you have considered here. Then what we will do, whenever we are reading the A's, you just pushed onto the stack. While we are reading the second A, then it is also pushed onto the stack. While we are reading the B, then this is a no change condition. Consider it as no change condition. Don't do any type of pushing or popping while we are reading the B. Okay. So while we are reading the C, then pop A. While we are reading the second C, then pop A. Why? Because here number of A's and number of C's are equal. So that's why number of push operations and the number of pop operations should be equal. So that's why we will do the pushing and popping for A and B. While we are reading A, we will push. While we are reading C, we will pop. Okay. And in the middle, if you are having B symbol, only one symbol. So that's why it is a no change condition. Even if you are taken 2 B's also, then take it as a no change condition. You already know that how to write the transition functions. Okay, for example, Q0 state A and Z0. If it is a pushing operation, what we will do? We will write the state Q0, and pushing means combination of these two symbols A, Z0. If it is pop means state, here we will write the state and epsilon symbol. For example, if it is a no change condition, here we will write the state and what is the last symbol we are having, otherwise top element of the stack, so that symbol we will write here as it is. Okay, so apply these transition functions to this concept while we are reading each and every symbol. Okay, that's it.